Hello my dear students. Welcome to Teacher at Home. Today class we are going to learn the 13th chapter. That is what does it deals with? It deals with the motion and time. Motion itself movement. In class 6 you learned about different types of motion. Learned a motion could be along a straight line, it could be circular or periodic. Can you recall the types of motions that you had studied? Identify the types of motions. The soldiers in a march past. That is in a straight line. Bullock cart also straight. A straight or circular curve will be there. Pedal of a bicycle, that is movement is circular. Motion of the earth also circular. Motion of a swing also circular, and that of the pendulum is found to be circular. We know that some vehicles move faster than others. Even the same vehicle may move faster or slower at different times. Make a list of 10 objects moving along a straight path. Group the motion of these objects as slow and fast. How did you decide? That is, if vehicles are moving on a road in the same direction, we can easily tell which one of them is moving faster than the other. It shows the position of some vehicles moving on a road in the same direction at some instant in time. Now look at this. It shows the position of the same vehicles after some time. From your observation of the two figures, answer the following questions. That is, which vehicle is moving the fastest of all? The distance moved by the objects in a given interval of time can help us to decide which one is faster or slower. For example, imagine that you have gone to see your friend at the bus stand. Suppose you start pedaling your bicycle at the same time as the bus begins to move. The distance covered by you after 5 minutes would be much smaller than that covered by the bus. We often say the faster vehicle has a higher speed. In a 100-meter race, it is easy to decide whose speed is the highest. One who takes shortest time to cover the distance of 100 meters has the shortest time, means it will be having high speed. Speed. You are probably familiar with the word speed. Every day we are hearing the word speed. In the example given above, the higher speed seems to indicate that a given distance has been covered. Higher speed, what does higher speed indicate? That the distance covered in a shorter time. Time will be short, or a large distance covered by a given time. The most convenient way to find out which of the two or more objects is moving faster is to compare the distance moved by them in unit time. It refers to the distance that is being moved in a unit time. Thus, we know the distance covered by two buses in 1 hour, we can tell which one is faster. We can call the distance covered by an object in a unit time, it is the speed of the object. When we say that a car is moving with a speed of 50 kilometers per hour, it implies that it will cover a distance. How many kilometers? 50 kilometers in 1 hour. However, a car seldom moves with a constant speed for 1 hour. In fact, it starts moving slowly and then picks up speed. So when we say that the car has a speed of 50 kilometers per hour, we usually consider what we consider the total distance that is being covered in 1 hour. We do not bother whether the car has been moving with a constant speed or not during the hour. The speed calculator here is actually what? The average speed. So the speed calculator, it is the average speed of the car. In this book, we shall use the term speed for average speed. For us, the speed is the total distance covered by your total time taken. So actually speed, it is implied as the total distance covered by the total time taken. In everyday life, we seldom find objects moving with a constant speed over long distance for a long duration of time. If the speed of an object moving along a straight line keeps changing, that is, if the speed keep on changing, its motion is said to be non-uniform. On the other hand, an object moving along a straight line with a constant speed, it is said to be uniform motion. In this case, the average speed, it is same as the actual speed. We can determine the speed of a given object once we can measure the time taken by it cover to a certain distance. You learned how to measure the distance also. Measurement of time. If you do not have a clock, how would you decide what time of the day it is. Have you ever wondered how our elders could tell the approximate time of the day by just looking at shadows? Our ancestors noticed that many events in nature repeat themselves after definite intervals of time. For example, they found that sun rises every day in the morning. The time between one sunrise and the next was called a day. Similarly, a month was measured from one new moon to the next. A year was fixed as the time taken by the earth to complete one revolution of the sun. Often we need to measure intervals of time which are much shorter than a day. Clocks or watches are perhaps the most common time measuring devices. Have you ever wondered how clocks and watches measure time? The working of clock is rather complex, but all of them make use of some periodic motion. One of the well-known periodic motion is that of the simple pendulum. A simple pendulum, see this is the picture. It consists of a small metallic ball or a piece of stone that is suspended from a rigid stand by a thread. The metallic ball, it is called as the bob of the pendulum. See here, this is metallic ball that is called as the bob of the pendulum. Shows the pendulum at rest in its mean position. So when it is starting, it is at rest. When the bob it is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of what? A periodic or an auxiliary motion. Periodic or oscillatory motion. Pendulum it is said to have completed one oscillation when its bob started from its mean position O. So it is said to be in one oscillation when the bob started at mean position O. It moves A to B and back to O. The pendulum also completes one oscillation when the bob moves from one extreme position A to the other extreme position B and comes back to A. Time taken by the pendulum to complete one oscillation. It is called as the time period. Time taken by the pendulum to complete one oscillation is known as the time period. Set up a simple pendulum as shown with a thread or string of length nearly 1 meter. Switch off any fans nearby. Let the bob of the pendulum come to rest at a mean position. Mark the mean position on the bob on the floor, below it, on the wall behind it. To measure the time period of the pendulum, we will need a stopwatch. However, if a stopwatch is not available, a table clock or wristwatch can be used. To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is taut while you displace it. Now release the bob from its displaced position. Remember that the bob is not pushed when it is been released. That is, the to and fro motion of the bob has to be counted and the time have to be noted. Note the time of the clock when the bob is at its mean position. Instead of the mean position, you may note the time when the bob is at the extreme positions. Measure the time the pendulum takes to complete 20 oscillation. So we have to record the 20 oscillation, how much oscillation it has been taken and how much time it is taken. Record your observation. The first observation shown, it is just a sample. Your observation could be different from this. The first observation is shown is just a sample. Your observation could be different from this. That is, we have to repeat the activity a few minutes and we have to record our observations. By dividing the time taken for 20 oscillations per 20, get the time taken for one oscillation. So if you are taking the time taken for the total oscillation per one oscillation, we get the time period of the pendulum. Is the time period of your pendulum nearly the same in all cases? You have to note it. Okay. The cells in which, that is, we are having most clocks or watches have an electric circuit with one or more watt cells. These clocks are called quartz clocks. The time measured by quartz clocks is much more accurate than that by clocks available earlier. So quartz clocks, it shows the time more accurate than that is available now. Unit of time and speed. The basic unit of time is second. And it is simply says larger unit of time are minute and hours. You already know how these units are related to one another. What would be the basic unit of speed? Since the speed is the distance by time, the basic unit of speed, it is meter per second. Of course, it could be expressed in other units such as meter per minute or kilometer per hour. Symbols of all units are written in singular. It is 50 kilometer. Instead of kilometer, we are written in kilometer, not as kilometers. Okay. The discovery that the time period of a given pendulum is constant. We might have heard the name of famous scientist Galileo Galilei. It said that when Galileo was sitting in the church, he noticed the lamp that is being suspended from the ceiling with a chain and moves slowly from one side to other. He was surprised to hear that a pulse beat the same number of times during the interval in which the lamp completed one oscillation. So the pulse is same as that of the oscillation of that what lamp. Various pendula to verify this observation. Pendulum of a given length take always the same time to complete one oscillation. We are using winding clocks and wristwatches, were refinements of the pendulum clocks. Different unit of time are used depending on the need. For example, it is convenient to express your age in years. That is how we are expressing our age in years, not in days or hours. It will not be wise to express in years the time taken by you to cover the distance between your home and the school. Time taken in saying 2001 is nearby 1 second. Verify by counting aloud, that is 2001, 2010, etc. The pulse rate of a human being is 72 per beats per minute, 12 times in 10 seconds. And we are considering this, many time measuring devices were used in different parts of the world before the pendulum clock became popular. Sundials, water clocks, and sand clocks are some examples of such devices. Different designs of these devices were developed in different parts of the world. Measuring speed. Having learned how to measure time and distance, we also are able to calculate the speed traveled by the ball. Draw a straight line on the ground with a chalk powder or lime and ask your friend to stand 1 or 2 meters away from it. Let your friend gently roll a ball along the ground in a direction perpendicular to the line. Note the time at the moment the ball crosses the line and also when it comes to rest. That is when it comes to crosses the line and also when it comes to rest. The smallest time interval that can be measured with commonly available clocks and watches is 1 second. However, now special clocks are available that can measure time intervals smaller than a second. Some of these clocks can measure time intervals as small as 1 millionth of even 1 billionth of a second. You might have heard that the terms like microsecond, nanosecond. 1 microsecond is 1 millionth of a second. 1 nanosecond is 1 billionth of a second. Clocks that measure such small intervals are also used for scientific research. Time intervals as 1/10 or 100 of a second. The ages of star and planet also are expressed in billions of years. That is the measure. What is it given? Sundial at Jantar Mantar, Delhi. Then sand clock, water clock. Measure the distance between the point at which the ball crosses the line and the point where it comes to rest. You can use a scale or the measuring tape. Now different groups to repeat the activity. You may now like to compare your speed or walking or cycling with that of your friends. You need to know the distance of the school from your home or from some other point. Distance of the school from home or some other point. Each one of you can then measure the time taken to cover the distance and also calculate your speed. Speed of some living organisms are also given. Rockets launching satellites into Earth's orbit often attain speed up to 8 km per second. On the other hand, a tortoise can move only at a speed of 8 cm per second. Once you know the speed of an object, you can find the distance moved by it in a given time. That is, if you are knowing the speed of an object, we can see the distance moved by it in a given time. How can the distance covered is speed into time? Find an object you would cover to a distance while moving with a given speed. That is, for this we are using several meters can be seen in the dashboard of cars, buses and also in other vehicles. This is being referred to as the speedometer. It records the distance speed directly in kilometer per hour. There is also another meter that measures the distance moved by the vehicle. So the speed can be calculated using speedometer and the distance can be measured up by odometer. While moving for a school picnic, Paheli decided to note the reading on the odometer of the bus after every 30 minutes till the end of the journey. Later on, she recorded her readings. That is, they had started. Whether she can tell how far they would have traveled till 9:45 a.m. Paheli had no answer to this question. They went to their teacher. She told them that one way to solve this problem is to plot a distance time graph. What it is given, a odometer in which a time distance graph it is taken. That is, they had taken started 8 a.m. and ended up in 10 a.m. So from starting from the 8 a.m. the distance that is being read in the odometer is 36,540 kilometer. Distance from the starting point, always the distance from the starting point will be 0 and the distance covered till the last point is 80 kilometer. This type of graph shown, it is known as what? Bar graph. And the type of graphical representation is also there. It is known as a pie chart. Distance time graph is a line graph. Pie chart showing composition of air, oxygen, other gases, nitrogen. Take a sheet of graph paper, draw two lines perpendicular to each other. Mark the horizontal line as x0, x bar up. It is known as x-axis. Similarly, the vertical point is y0, y dash. It is known as the y-axis. The two quantities between where the graph is shown, it is along the x-axis. Positive values on the x-axis along OX. Similarly, positive value on the y-axis shown along OY. That is the motion of the car. It is taken time is 0, distance also 0. The time it goes on increasing from 1 to 5 and the distance also seems to be goes on increasing from 1 to 5. Draw two perpendicular line to represent the two axes and is marked as OX and OY. This is all regarding the how to draw the lines on the map. Choose a scale to represent the distance and another to represent what? The time on the graph. For the motion of the car, scales could be time, that is 1 minute equal to 1 centimeter. Mark values for the time and the distance on the representative axis according to the scale you have chosen. Now you have to mark the points on the graph paper to represent each set of values for distance and time. The distance mode is 0. The point corresponding to a set of values on the graph will therefore be the origin itself. And draw a line perpendicular to x-axis and the line corresponding to the 1 kilometer on the y-axis. The point where these two lines intersect, it is the set of values on the graph. Making a graph means join all the points on the graph. It is a straight line, the distance graph for the motion in the car. Then what all given? Generally the choice of scales is not simple as in the, that is here another time distance time graph for the bus. So the another vehicle taken, it is bus. When it is started at 8 o'clock at 8 a.m. it is started and last point is 10 a.m. The distance is starting from the 0 ending in 90. Let us again consider the motion of the bus that took Paheli and her friends to the picnic. The distance covered and the time taken by the bus is shown. Total distance is 80 km. If we decide to choose a scale 1 kilometer equal 1 centimeter, we shall have to draw an axis, that is the length of 80 centimeter. The difference between the highest and the lowest values of each quantity, intermediate value of each quantity, so that with the scale chosen it is convenient to mark the values on the graph and to utilize the maximum part of the paper on which the graph is drawn. Suppose that you are given a graph that is 25 centimeter to 25 centimeter. One of the scales which meets the above condition and can accommodate the data of time. When compared that is everything it is represented, it is a graph, x and y axis it is represented and which position we have to draw the distance and which position we have to draw the time. That is given in this paragraph. If you are understanding and if you are interested in this, please do like, share and subscribe my channel. Okay, thank you.